Welcome back, everyone. So we have now explored the two uses of a mole in terms of the kinds of calculations that you will be doing. We first said that we could use this definition of a mole as a counting number, and that if we had 1 mole of something, that was Avogadro's number, or 6.02 times 10 to the 23rd of whatever we were counting. So that's one definition of a mole, using it as a counting number. We can also use a mole in terms of a mass, so as a way to weigh things. Catch that? We can say that 1 mole of an element is equal to its atomic mass, but in grams. So for example, 1 mole of carbon, as kind of what's shown up here in this example, 1 mole of carbon is 12.01 grams of carbon. And we get that 12.01 from the atomic mass of carbon, which is on the periodic table, which you'll be able to use for quizzes and exams. So that is the second definition of a mole. 1 mole of whatever substance you were dealing with is equal to its atomic mass in grams as a weight. So in previous videos, we've done calculations using either the Avogadro's concept of a mole to calculate numbers of atoms or molecules. We've also done problems where we used the mass example of a mole to do gram and mole calculations. In this little vignette, now we're going to put those two definitions together to do all one big calculation. So in this example, we're given a mass of an element in grams, and we are asked to determine how many atoms of carbon that is. Now, there's no direct one-step path from the unit grams of carbon to carbon atoms. We have to go through chemist's favorite unit, the mole, which is to first convert our grams of carbon into moles of carbon using the molar mass of carbon, written appropriately so that the units cancel. Now we're left with the moles of carbon in the numerator from just this first step. Then we go on and use Avogadro's number to go to carbon atoms. Written, of course, so that our units cancel, and so we're left with carbon atoms in the numerator, which is what we're looking for. So again, numbers in the numerator multiplied, numbers in the numerator divided, so 0.58, divide by 12.01, multiply by 6.02, don't need the second to, 6.02 times 10 to the 23rd, and that should give you 2.9 times 10 to the 22nd carbon atoms. So in this example, we've just taken both definitions of a mole and put them together to do one calculation. So in this example, we used grams of carbon. This next example, which I will let you read through on your own, similar setup, but we had grams of not carbon, but of aluminum. And we wanted to know how many aluminum atoms that was. Same dance, same two-step process of going from grams to moles, and then moles to atoms. But this time we use the molar mass, not of carbon, but of aluminum, because that's the substance we were given in the problem. And then the second step still uses Avogadro's number. And so then put into your calculator, you should get 3.62 times 10 to the 23. So that's a second example, same dance, same process of going from grams to moles and moles to number of atoms. So that's with elements. We can do the same kind of calculations, but with compounds. The only thing we need to be aware of, the only thing we need to do a little differently is instead of using the molar mass for the element, we need to use the molar mass for the compound. And so to find the molar mass of the compound, You just sum up the atomic masses of the elements that make up that compound, and then the unit on that molar mass is grams per mole. So for example, the molar mass of sodium chloride, NaCl, to find what its molar mass is, I need the molar mass of 1 sodium, which you get from the periodic table, add it to the molar mass of chlorine, again from the periodic table, add them up, and then that number in grams per 1 mole is the molar mass for that compound. So the molar mass of a compound is just the sum of the molar masses of the elements in it. So now you can see why it's really important to be able to write correctly balanced, correctly formed chemical formulas, because if your chemical formula is incorrect, then you're not going to have the correct molar mass to do your calculations. So let's keep that in mind about finding molar mass for a compound when looking at some other problems. Oh, and this is just to say that molar mass is sometimes also called formula weight. I tend to use the term molar mass more, but if you hear the term formula weight or read it in your textbook, it means the same as molar mass. So molar mass is used when going between grams and moles of a compound. So in this example, I had 1.75 moles of water. I needed to get to grams of water. The only way to go from moles to grams or grams to moles is the molar mass of that substance, which for water is 18.02, shown calculated here. That molar mass is written appropriately so that my mole units cancel. I'm left with grams in the numerator. And then doing that multiplication gives me 31.5 grams of water. Now let's go on and, still remembering that concept of molar mass and the concept of going from grams to moles and moles to molecules. Let's say I have a particular molecule and I have a certain number of them, and I wouldn't know how many grams of NO2, nitrogen dioxide, that is. Well, do this problem exactly as I've done the previous ones. Write down what I'm given, write down the unit I'm looking for, and then see what unit conversions I need to do to get to the desired unit. There is no direct path between molecules and grams. You got to go through chemist's favorite unit, the mole. So I first need to convert my molecules of NO2 to moles using Avogadro's number. Then I can convert my moles of NO2 to grams by using the molar mass of NO2. So what I just said is sort of shown here, but in more detail is shown in this slide. So let's go ahead and use that same thought process to attack this question, and that'll be the ending question for this little vignette I'm doing. Let's say I have this molecule, which is actually called a hydrate. We introduced them very briefly in chapter 5. This hydrate is copper 2 sulfate pentahydrate. And I want to know how many molecules of CuSO4 5H2O are in a 78.9 gram sample of that hydrate. So first thing I do, I write down what I'm given. I was given 78.9 grams of that substance. Give myself a lot of space to work the problem. Write down the units that I'm looking for. I am looking for molecules of copper 2 sulfate pentahydrate. And so as we've talked about, there's no direct path or no one step between grams and molecules. You have to go through moles. So we need to go from grams of copper 2 sulfate pentahydrate to moles. And the way that we do that is through molar mass. So we need to calculate the molar mass of copper 2 sulfate pentahydrate, which I've done here. So to find the molar mass, you'll need your periodic table handy, of course. And so looking at that balanced chemical formula, I've got 1 copper, 63.55. I've got 1 sulfur. And where does this 9 come from? I know that, I've got oxygen here, but 9? So I have 9 oxygens in this species because I have 4 from this part of the molecule. And then I have 5 because the 5 goes not only to the hydrogen but also the oxygen. So I have 5 oxygens from that part of the molecule. So 5 plus 4 is 9. So I have 9 oxygen atoms. Finally, I have 5 times 2 or 10 hydrogens. So that's where all of these numbers come from. Adding them up gives me the molar mass of copper 2 sulfate pentahydrate, which I will then use to convert my grams of copper 2 sulfate pentahydrate to moles. Again, writing that so my gram units cancel. I've got moles, but I got to get to molecules. So anytime you see the word molecules, ions, atoms, think, oh, those are things that chemists count. I'm going to have to use Avogadro's number to convert. So there's 6.02 times 10 to the 23rd molecules in 1 mole of that hydrate. Again, that written so my units cancel. I'm left with the molecules of copper 2 sulfate pentahydrate, which is the unit I'm looking for. So in your calculator, 78.9 divided by 249.72, multiply 6.02 times 10 to the 23rd, and that should give you the final answer of 1.90 times 10 to the 23rd. So this dance, again, of going from grams to moles, moles to molecules, that kind of calculation is going to be one that you will use often in this course. And in the next slide, in the next little video, we're going to do another review problem, this time using my favorite molecule, caffeine, to kind of solidify these concepts.